This video will discuss how to interpret the second derivative graphically. Let's recall what we have so far. We begin with the function f. We derive from that the derivative function f prime, which represents the rate of change of f. And f prime is also a function, so we can take its derivative as well. So this would be the rate of change of f prime. Since f prime measures slope, f prime prime measures the rate of change of the slope. Let's see what that looks like in practice. There are two possibilities for f prime. It might be increasing, the derivative is positive, or the derivative might be negative, so that it's decreasing. For each of these possibilities, we might have f prime positive or f prime negative. F double prime positive or f double prime negative. So we'll examine each of these two possibilities. Let's suppose that f prime is positive. That says f is increasing, so it might look like this, or it might look like this. In the first case on the left, the tangent lines are positive, as we would have positive slope as we would expect when f prime is positive. We see that the slopes are positive and getting more positive. That is, the slopes are positive and increasing. If the slopes are positive and increasing, the increasing part tells us that the derivative of the slopes is positive. So f double prime is positive. In the other case, we again have positive slopes, but the slopes are decreasing. They're getting flatter. So the rate of change of the slopes is negative because the slopes are decreasing. F double prime is less than 0. So if f prime is positive and f double prime is also positive, we have this kind of shape. If f prime is positive and f double prime is negative, we have this kind of shape. Let's see what happens if f prime is negative. Now we know f is decreasing. It might look like this, or it might look like that. The same kind of analysis of tangent lines, same kind of analysis of tangent lines tells us in the case on the left, f prime is negative, but the slopes are increasing. These are negative numbers that are getting closer to 0, so they're flattening out. So those slopes are increasing as numbers. So the slopes are increasing tells us that the second derivative is positive. In the case on the right, f prime is less than 0, but the slopes are decreasing. So we can see here they're negative numbers, but they're getting steeper. So they're smaller negative numbers. That is, they are more negative. So in this case, the slopes are decreasing. F double prime is less than 0. So to summarize, we have 4 possibilities. Here they are. Going from left to right, here the function is decreasing, so f prime is less than 0. In the second one, the function is increasing, so f prime is positive. In the third case, f is decreasing, so f prime is negative. In the last case, the function is increasing, so f prime is positive. In the leftmost one, we see, however, that the slopes are increasing, f double prime is positive. Here, the slopes are also increasing, f double prime is positive. So here we had negative slopes on the left we have negative slopes increasing, on the right we have positive slopes increasing. In the third case we have negative slopes that are decreasing, and in the last case we have positive slopes that are decreasing. The first 2 cases, with the positive second derivative, we say at such a place the function is concave up, or CCU for short. In the other cases, we say the function is concave down, or CCD, to abbreviate. So, concave up, concave down. And that's the story.